Internet. Okay, 1.4 polygons. First definition, what is a polygon? You can summarize it if you like. It's a closed figure in a plane created by 3 or more segments. The segments we're going to refer to as sides. And then the endpoints that connect the sides are called a vertex. The plural form for vertices okay. So again, some key things. Closed figure is really important. Made up of segments. Okay, 3 or more. Can't have 2 because then it wouldn't be closed. 2 makes up what though? What does 2 make? Angle. Angle. Okay. We call the segment sides. Okay, and then the endpoint is called the vertex. Vertices or plural. Know all that terminology. Okay. Here are some examples of some polygons. I think you only have one on yours. So basically, yeah, let's figure made up of segments. That would be a quick, easy way to write that. Okay. So let's see. Oh, let's see. How many vertices does the arrow have? 7. Yeah, 7 vertices. How many segments does the arrow have, Logan? 7. How many vertices does the star have, AJ? 10. Good. How many sides, Ryder? 10. So do you think that the same number of vertices is supposed to be the same as the sides? Okay. All right. So vertices, sides, okay, closed figure. Okay. All right. Next one. These are not polygons. So what are some characteristics that are not polygons? We can just list those down in bullet form. So not a polygon is the next one. What's one? Curved line. So right, just like bullet, curve. Okay, or curved line. Open, it's open or not closed. Intersecting lines or intersecting segments. Good. That's true. This would really be 2 different polygons, right? A small triangle and a bigger triangle. So yeah, that one could be, but I think what they meant by it, this was an intersecting segment there, and you can't do that. All right, so it's open, curve, and intersecting. Okay. That's pretty good. That'll be good. We don't need to know a whole lot about that. Just main thing is the curve. Okay, parts of a polygon. Parts of a polygon. So here's what the side looks like. Like a segment. So you'll hear me talk about consecutive sides. Okay? That means they're right next to each other. The picture didn't print out all the way. Make sure you copy it and label it correctly. Here's a vertex here. How many vertices does this one have? 5. Okay, good enough. And then here's some consecutive vertices. And you can have more than just 2. You can have like 3 consecutive vertices. Or 4. Okay, depends on how big the shape is. Okay, so there's how you physically see those on the picture. Here's the real important part. So we name everything, right? We name points, we name lines, we name rays. Here we can name the polygon. So here's how you name the polygon. All you do is list the vertices in consecutive order. That's it. And you can start with whatever letter you want. Okay, so most of the time we go in alpha order. So here's how you can name that one. You don't have to write out this word though. Like the pentagon, you don't have to write that out. Okay? Usually, I'll just flash that like that. Usually you just have to do that part only. AJ you start with C and your neighbor over there starts with A, that's okay. There's nothing wrong with that. You can start with whatever one you want. Just make sure you go counterclockwise or clockwise. One or the other. It's how to go in order. Okay, so be able to name the polygons on your homework. You guys still ready? Alright, so name the polygons. Okay, so naming and classifying are two different things, right? Naming is with the letters, the points, the vertices. Classifying, so maybe highlight that classify. So classify, okay? These are the names. A lot of y'all know most of them, okay? But the ones you don't know, I just highlight those. Like I know everybody messes up on that one, this one, that one. Okay? All right. So go ahead and write all the numbers down. Starts with 3, right? Because we can't have a two-sided polygon. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and in. Just write them down on the left side. And then start listing the ones that you do know. What's the first one? Good. This one I'm in here. I know several answers. What's this one? Square or rectangle. So what do we have to do? List all of them as square or rectangle or trapezoid or cylinder. There's only one right there. What is it? What? Quadrilateral. Okay? We can't say square or rectangle or trapezoid or, yeah, we can't say all of them. So we say quadrilateral. There's actually two sections from now we're going to talk about all those special quadrilaterals. Okay? Next one is hexagon. What's the next one? Hexagon. H-E-X. This is the one that everybody forgets. It doesn't start with an S. Anybody? Oh, that's the one. No, I was like, at least one in my last class. I know there's more to show, but isn't that like a one person knew that one. He didn't say it loud enough, so he wasn't confident. He was embarrassed to get it wrong. After somebody put nine-agon, that's the only time that I'll count for spelling. Okay? Okay, because you're saying nine-agon, so the number 9 is not a okay? Decagon. Hey, look, I know nobody knows. Don't ask Siri. It has something to do with not Greek, like Latin and French. Undecagon. Okay, so the way you say one in French or Latin is or you get it. And then decagon has how many? 10. So what's 1 plus 10? 11. So that's one way to remember it. Latin or French? Spanish is kind of like it, except for minus the O. And 13? Just 13 done. So when we get to 13, 14, 15, and so on, you just say the number, okay? Because you make up that many names, okay? How many sides does N represent? Which is any number, okay? So these are all technically ingots as well, because those are numbers. So you just say ingot. So like on the test question, I put on there how many sides does an ingon have, and I got answers like 13 and up. These are still ingons too. Okay? These just have more specific names. In is any number, okay, other than 2 and 1 and 0 and all the crazy numbers. Okay? So in represents any number. Okay? So if I ask you that on your test, and how many sides does an ingon have? And say in, okay? In number of sides. If you were to actually say 3 on up, I would accept that. Okay? Not 13 and up though. Okay? Alright, so know those names since this table will be on your next test. I'll give you like one or the other side, and you have to fill that out. Okay? Okay, diagonal next. Diagonal is segments. Okay? See, so you have the name still. So that one has the bar over the 2 letters. Okay, it's a segment that connects any 2 non-consecutive vertices. That's easy right there. Non-consecutive vertices. So here's a picture of a diagonal. That turquoise one. Could you have more than one diagonal in a polygon? Could you have 0? And which one could you have 0? Square has some. Triangle has no diagonal. So you can have 0, or you can have a lot, or you can have a ton. You're going to actually figure out like an equation, okay, for the pattern of how many diagonals for any number of polygons. So like, you'll be able to answer this question, how many diagonals does a 1,000-sided polygon have? You'll be able to tell me. Okay? Yeah. Next unit, we go over that. Okay? How many diagonals does a pentagon have? 5. 5? 5. 1, 2, 3, 4, 5 diagonals. Okay? Next one, convex polygons. Convex is a polygon that has no diagonals outside. So here's some examples of some convex polygons. I think you only have like 1 or 2 on yours. There's a lot. The purple segments are all the diagonals, and you can see none of them end up being outside of the polygon. Outside of the polygon. They're all inside. You see any of those diagonals on the exterior part of it? So technically, aren't all polygons? We'll see.
Well, look at the star.
Okay, so there you go. Now you're thinking. Did you see the star polygon earlier? That's not a convex, because if I connect the 2 points of a star, doesn't that diagonal end up being outside? See? So, it can be outside if you think of the star polygon. Alright? Or that arrow polygon. Okay, so, everybody got this one? Okay, so concave polygon is a polygon in which you can have at least 1 diagonal outside. Okay, so I'm going to show you some examples there, because some of y'all looked a little dumbfounded as to how a diagonal could be outside of a polygon. So for instance, right here, this one right here, if I connect this vertex with this vertex, isn't that going to be outside of the polygon? So now that's 1. How many does this one? How about that one? Alright, so if it goes outside, it's concave. The key word that I've told students in the past is You need at least one. All right, perimeter. Y'all did this in middle school, okay? All you do is add up all the sides. So, real quick, what's the perimeter of that one? How much? 30. Okay? All you do is add up all the sides. Now, how might they make this more difficult for us? Use algebra. They'll do x plus 2x plus 3x plus 10x, and then give you a value and make you solve for the x or whatever. Okay? Okay, next one. Equilateral polygon. Equilateral polygon. This is a polygon where all sides are equal. It's got its own name. Okay? Equilateral, equal sides, or congruent sides. Notice the tick marks. If you see these tick marks, that means they all have the same exact size. Okay? Equilateral, polygon with all sides equal. Flip to the next one. Next one is called equiangular polygon. That's the second one. All the angles are equal, so that's what these little marks look like right here. Okay, so all the angles need to be equal. And so then if you put both of them together, where you have it also equilateral and equiangular, then that means you've got all the angles congruent with all the sides. Okay? So all sides and all angles equal. So if I tell you to sketch a regular hexagon, then you need to put all those tick marks on everything. Okay? And sketch it the best way you can. Alright, we good? One more slide. Last one is congruent polygons. What does congruent mean? Because you dealt with congruent angles. Same size, same shape. So if you want to write that down again, you can do that. This one, of course, polygons are going to be the exact same size and shape. So you have to have all corresponding angles and all corresponding sides congruent. So let me show you these two pictures. You've got this polygon, and you might need to draw in some of it on your picture because I think it got cut off. Those are two polygons that are congruent. You can see everything matches up and everything. Why is what? Okay, so like an example would be polygon CAMP is congruent to light. Okay, you have to write it in perfect order, okay, because you can write it out of order. Okay? So if you're saying S first, then you're telling me that S is congruent to C. Yes? Okay, so it has to be, it has 4 tick marks, that has 4, so that is right. Okay? And then I is second because it has 3 tick marks, A has 3, so A needs to go with I, and T and then T. So they all correspond. If you don't write it in order, it's going to be wrong. Sometimes they like to trick you. Notice how this is the word and sight, right? Sight. They like to trick y'all sometimes, and they'll make it a word, but it's really, you don't spell it that way, they reverse the letters. Okay? But you're like, oh, it spells this, so let's just write that word out. And do that. You have to make sure the angles correspond. Okay, so do a good job with it. Alright, so everybody understand what it means to be congruent and how everything needs to correspond? Okay? Alright, one more. Okay. Couple of examples from the page. You can couple of examples on the back. Okay, if you need a protractor, then just watch me and sketch it. If you have your own, Open up your book. Everybody's still writing. Okay, so it says use your geometry. So you're going to want to pay attention because this is on your homework and this is worth a lot of points on your homework. It says use any geometry tools to create a pentagon. So I want to highlight that. How many sides do we need? 5. With 2 consecutive side lengths of 4 centimeters and 3 consecutive angles that are 100 degrees. Okay, so here's how you're going to want to do this. So you get your ruler and your protractor. Okay, and so I'm going to start off with my 4 centimeter side. So I get my pen and I draw a 4 centimeter side length. There it is. Alright, now I have to have 3 angles in a row measuring 100 degrees. So what I'm going to do is from my 4 centimeters, I'm going to write 4 centimeters. From my 4 centimeter side length, I'm going to go ahead and make 2 100-degree angles on those endpoints. Why not? Might as well get it out of the way. So here's 0. I'm going to go all the way to 100. I'm going to make a dot right there, and then that's where I know I can connect my ruler. Then I'm going to go to this other endpoint. I'm going to make a dot there. So here's 0. All the way to 100 is right there. Okay, so see how I just made a dot? That's how you're going to use your protractor, which you have this on your homework again. So if you don't have a protractor, you're going to want to do this first. So I'm going to line this up right there. Now, I need consecutive 4 centimeter sides how many times? 3? No. 2. So I'm going to just go ahead and do another 4 centimeter segment and get that out of the way too. So there's 4. So see how I'm lining up? I don't have to go all the way to that dot. So there's 4 centimeters. And I took care of the 100-degree angle right there too. So now I'm going to come over here. And I'm going to line that up too. Does this have to be a certain size? No, it does not, because I already did my 2 consecutive 4 centimeter sides, right? So this one can be whatever size you want it to be. About right there.
So it isn't 40.
It could be 4 if you want it to. Alright, and so then this is another 100-degree angle. Am I done? I need, what else do I need? I need one more 100-degree angle, so I'm going to go from this point right here. Notice you have to turn your protractor so that it ends up being on 0. And then your 0 of all the way to 100. Right there. Then I'm going to line my ruler up. There. And then I don't want to go all the way that way too far, because I just don't want it to be concave. But it could be concave, right? Did it say it had to be convex? No, so that's why I can be on your homework. So I'm going to go here, stop right there, and then I'm going to just use my ruler to connect those 2 right there. Right there. And there's my pentagon. 1, 2, 3, 4, 5 sides. Oops, let me mark my last angle. What then did I do 100? 7, right? Yeah. So that one was 100, that one was 100. So do I have 3 in a row? 3 consecutive? Yeah. Do I have 2 in a row for the sides? And so then that's how you'll do this problem. You're going to have one very similar to this here in a second. Okay, so use the protractor, use the